Dear students, today we will discuss chemical bonding. The very simple part of chemical bonding, that is the beginning part, that is electron dot structure, that is Lewis dot structure. But I'll represent that electron dot by different way. I'll take new concept. I'll take some additional idea, that is electron dot resides in orbital, and see how it is a powerful weapons. You can break, you can make any structure, you can draw the organic reaction mechanism. But remember, what I am giving today, that will not give the three-dimensional stereochemical shape of the molecule. That idea you will get from every digestion. But I'm going to give the idea how you will draw the structure. And it is very powerful impulse to draw organic molecules structure as well as to draw the resonating structure. How simply I will focus and how simply I draw the structure of different simple molecule and complicated molecule. See, the condition to form a bond. Let there is an atom A, and you know from plus nitrate concept, one electron from A, another electron from another atom B will share to form a covalent bond. And you know covalent bond and ionic bond. Covalent bond is a directional bond, ionic bond is a non-directional bond. That is nothing but electrostatic attraction. But A dot, A with one electron, or you can put dot. Now you know this electron, where it will reside? It will reside in orbital. And you know in an orbital, there are two maximum number of electrons may reside. And I am drawing the orbital. This is an orbital. It may be anything. I'm not drawing the exact shape of the orbital. This is an orbital, schematic diagram. And there is an electron. B another atom. I'm taking another color. B another atom. There is an orbital. And there is an electron. Now, A atom with singly occupied orbital and P with singly occupied orbital will share to form a bond, that is covalent bond A and B, two orbitals, and both will use these two electrons. Actually, they form a sigma or covalent bond. You can simply represent it A bond B. At C, where A atom with singly occupied orbital, B atom with singly occupied orbital. Singly occupied in which sets? Electron. Overlap or shear, they form a bond between A and B. And see, the formal charge is 0. No charge you will get on A or on B, since they share equal number of electrons. Now, let A with a pair of electrons. You know in an orbital, they are present maximum 2 number of electrons. And take B with vacant orbital. Now, here also can form bond. A will get both electron to this. And you will get here A, this is orbital, and B, it's orbital, and both electron comes from A. Remember, both electron comes from A. To form a bond, one electron required from A, another electron required from P. Actually, both electrons from A, that means one electron gives to the B, and one electron gave to the B, that's why it's formal charge plus 1, it's formal charge minus 1. And you can write it A, B, A with formal charge plus 1, B with formal charge minus 1. Now, what idea you got from here? To form a bond, electron is not the essential condition. Condition is orbital. What orbital required to form what bond? That orbital may be singly occupied. If it is singly occupied, then it will form bond with a singly occupied orbital and no formal charge you will get on atom. Now, if an atom is fully occupied, then also it can form bond with a vacant orbital. Normally, in the foundation course, we'll say it is a coordinate bond, but really it is a covalent bond. Both electron donated by A, and here B is acceptor, and actually A donate one electron, and you will get there also a covalent bond, and with formal charge A donor plus 1, B acceptor minus 1. That is vacant orbital, occupied orbital, singly occupied orbital, all orbital can form bond. Electron is not the criteria. See, in B, there is no electron, but there is an orbital that can form bond with fully occupied orbital. Remember also the formal charge created on atom. When singly occupied orbital form bond, no formal charge. When fully occupied orbital form bond, then the donor will get plus 1, acceptor will get minus 1. And this bond I have shown here sigma. It may be pi. It may be pi. Any kinds of bond can form. The essential criteria is an orbital. Now I break the bond. How bond breaking will occur that way. I'm going to show you. See, A bond B. That you know the originally there are 2 orbital and 2 electron. 6, no formal charge on A and B, that is 0 formal charge. Now if I break this bond, let B both electronegative, A electropositive. Both electron if I break on B, what you will get? You will get A. Both electron boson B, A with a vacant orbital and plus charge. Since you know, on these 2 electrons were one of A, another of B, and B, both electron taken by B, and there we get a pair of electron with its minus charge. This cleavage of bond is called heterolytical cleavage. Remember, it is called heterolytical cleavage of bond. Heterolytical cleavage. Now, when you will break a bond heterolytically, what you got? You got a plus charge with a vacant orbital. With a vacant orbital, remember it is, and P minus charge with a fully occupied orbital, or you could say lone pair. Now, the reverse phenomena, see the reverse. You can form a bond between a plus and minus, but it is not always. If plus with vacant orbital and minus with a pair of electron, then you can form a bond. And you know it is donor, it will get plus. Already there is a minus on plus. That means it gets neutralized. And it is plus, it will accept a pair of electron, you will get minus on plus. That means it is neutralized. This is called heterolytical cleavage of bond. Now I am going to show another pattern of cleavage of bond. That is, let here A bond B. And you know a bond means there are 2 orbitals and 2 electrons. Now I'll break this bond. 1 electron goes on A like this one, another electron goes on B, this one. This is called homolytical cleavage. Remember, homolytical cleavage. Focus on the term homolytical, equal. You know this electron, one of A, another of B. Now that electron goes on A, and another electron goes on B. And what you will get? You will get A with a single electron and B with a single electron. That is the backward phenomena of the formation of bond. You know bond energy. Bond energy has those. When a bond will form, an amount of energy released. That is the negative side according to our energy IUPAC convention. And when you want to break that bond, energy is required. That is plus sign. So there is no sign of actually bond energy has no sign. That will depends on the phenomena. If bond will form, negative sign. If bond is going to break, then positive sign. Now I take the real example of bottle. A real example. I'll form real molecule from the atom. Very simple molecule first. Then I'll go to the complicated molecular structure. I'm taking a simple example. Now, dear students, we are going to give real example of simple molecule. Then we'll go to the complicated molecule. But remember, keep in your mind that concept. That is, to form a bond, one orbital is the essential condition. Without orbital, you can't form a bond. That orbital may be with single electron, maybe with a pair of electron, it may be in the packet. Now, for example, in a simple molecule, I'm taking oxygen. Oxygen is a very simple molecule. Oxygen, two atoms. You know the formula of the oxygen is this. Now I will draw the oxygen molecule how for. Now tell me, what is the valence electrons of oxygen? 6. There are valence number of electrons of oxygen atom is 6. Now tell me the number of valence or atoms of oxygen. You know oxygen atom belongs to period 2. And all atoms which are belongs to period 2, their number of available orbitals or number of valence orbitals always 4. 2s, 2px, 2py and 2pz. That means number of available orbitals of oxygen atom, not only oxygen atom, all atoms belongs to period 2, number of available orbitals always 4. And electron 6. Now you know for a bond, to form a bond, one orbital and one electron is required. You know the valency of oxygen is 2. Now put 2 number of bonds. Now I count the remaining part of each oxygen atom. See, 2 number of bonds means 2 number of orbitals already involved to form bond. Now tell me the number of remaining orbitals. Total number of orbitals 4. 2 number of orbitals involved to form the bond. The remaining number of orbitals is 2. Each oxygen atom has 2 number of remaining orbitals. You can draw the orbitals like this. Now the number of remaining electrons, total electrons 6. 2 electrons involved to form the bond. The remaining electrons 4. And you know in an orbital maximum 2 electrons can reside. That is 4 electrons into orbital, put 4 electrons into orbital, maximum 4 you can put. This is the structure of oxygen molecule. O double bond O, and on each oxygen atom you will get 2 number of lone pairs. Now, from this oxygen molecule, I'll form a complicated molecule, ozone. How I'll form ozone? See, the magic. Take another oxygen. Suppose go to what? So, now you got the structure of simple oxygen molecule. Now the magic is I'll form a complicated molecular structure of ozone. How I will form ozone from oxygen? See, you know the formula of ozone, change it O3. That means O2, already I have drawn the structure, plus O. Now, how you will get the structure of ozone? You know, oxygens have 4 orbitals in its valence shell that I have told you many times. Draw 4 orbitals. I have drawn here 4 orbitals. And you know the valence number of electrons of oxygen is 6. And put 6 electronic 3 orbitals. Packet 1 orbital. Packet 1 orbital. The question may arise from the student's end. Sir, how can packet? You know the ground state electronic configuration. 2 orbitals are with single electron. Take energy from the surrounding and make it pure, no problem. You know when a bond will form and huge amount of energy will come. That means huge profit will come. And I have packet 1 orbital, since you know this occupied orbital can form bond with only the vacant orbital. That's why the 6 electron I have put it in 3 orbital and 1 orbital I have vacated. Now you know this fully occupied orbital and this packet orbital will form a bond. Like the previous concept. Now make ozone, oxygen, double bond oxygen, and you know one oxygen is donor. Here we get 3 load pair of electron. Since it is acceptor, here we will get formal charge on this oxygen -1, and here we will get 1 load pair. One is invert to forward. This is donor plus charge. That is the my previous concept. Donor is +1, acceptor is -1. Now you got the structure of ozone. Now the another important part. Let it is marked. This is oxygen number 1. This is oxygen 2. This is oxygen 3. Now see the structure. This oxygen double bond oxygen. You know bond multiplicity, if increases, then bond length decreases. So this oxygen 1 and 2 length should less. And this is single bond, this length should higher. But experiment will take both oxygen bond lengths are equal. How you would explain it? That is pseudo resonance, another canonical form. If I take another canonical form, give this load pair. Sir, why I will give this load pair? Since oxygen plus has no vacant orbital, break it. And heterolytical cleavage will form another plus with a vacant orbital. This is minus. And another plus with vacant orbital make a bond. That means it gets minus. Here is a 2 lone pair. That means now it is minus 3 load pair. 3 load pair. And it becomes single bond. This is plus with 1 load pair. And this is oxygen gets neutralized now by donating its electron pair. Now see, this is oxygen 1, this is oxygen 2, this is oxygen 3. This is canonical for 1, this is canonical for 2. See, both are equal with energy, equal in energy. How? Both have equal number of bonds. All are oxygen atoms, both are equally stable, both have equal energy. That means in the real structure, both have contribution 50-50. And see, 50% double bond O1, O2 and 50% single bond. Do average, what you will get? 1.5. Here also 50% single bond, 50% double bond. Total bond 3, total structure 2, 3 by 2, 1.5. That means the resonance hybrid, if I draw it, then this is O single bond, O single bond, O. Actually, the odd is 50% pi, make it dot. Dot means 50%. It is always plus, but the minus share 50% on oxygen 3, minus share 50% on oxygen 1, and also divide it minus half and minus half. Now, this two canonical form or hybridization of these two canonical form, if I do mix the two canonical form, if I take the average result, then bond order is 1.5. Number of bonds between the oxygen atoms. Formal charge on middle oxygen is +1 and the minus half terminal to oxygen. Now this idea will make both oxygen bond length are same at the formal charge of terminal oxygen minus of middle oxygen always +1. Since you see in canonical for 1 and in also canonical for 2, both have plus charge on middle oxygen. But in 1, right side -1, in 2, left side -1. To average 50-50, you will get minus of. Now this resonating structure, two different presentation or two different canonical form give clean idea about the equal bond order, equal bond energy, and the formal charge or terminal oxygen and formal charge on middle oxygen. Now, see, focus on the drawing and see how a complicated molecule O3 I have drawn from a simple concept, that is the essential criteria to form a bond is orbital. It may be with one electron, it may be with load pair of electron, it may be vacant. Now I'll go to give another example. Nitric oxide. You know the formula of nitric oxide is NO. This is N. Right, first, nitrogen, and nitrogen valency 3 due to singly occupied C orbital, its valency 3. And oxygen valency 2, since there are two number of orbitals with single electron, that is 2. And you got valency from the configuration. Now again write nitrogen and oxygen. Its valency 3 you got, its valency 2 you got. Now tell me which one limiting valency. Limiting means less valency, that is oxygen. Put less or limiting valency, that is 2. Oxygen now becomes saturated valency 2, but nitrogen now it is unsaturated valency 2. Since you know the valency of nitrogen is 3. But when there are two different atoms, always make it clear. Put limiting valency, not maximum valency. Put limiting valency. 3 do. I have drawn here two number of bonds. Now I do count the remaining number of orbitals and remaining number of electrons. You know two orbitals involved, remaining orbitals 2. Here also two orbitals involved, remaining orbitals 2. You know nitrogen valence electron 5. Two number of electrons involved to form the covalent bond with oxygen. The remaining number of electrons is 3. Put one electron in this orbital and in another orbital with 2 electrons. 3 electrons remaining. Oxygen, you got 4 electrons remaining. You got the structure of it. But one important thing here. See, your octet is below. 2 plus 2 plus 2 plus 2. You know every period 2 element try to get octet nearest near. But nitrogen, see, 2 plus 2 plus 2 plus 1. 7 electron system. Its electric number of electron around nitrogen in NO is 7. It is less than octet. And moreover, it is odd electron molecule. And you know, odd electron molecule always paramagnetic species. Paramagnetic species. You know what is paramagnetic? Paramagnetic species are those species which are favorably attracted by the magnetic field. Favorably means weakly. So nitric oxide is a paramagnetic species due to this odd electron. And remember, it is less than octet system, odd electron system. Now you got NO. Now I'll go to find a complicated molecule or species of this NO. Before going to discuss another molecule, I told you it is a 7 electron system. And period 2 element has the nature or trend to get octet. Now my question is, how it will get octet in a molecule? Very simple. Take, so one electron will taken by nitrogen of NO, it automatically becomes octet. Let one electron. If nitrogen of NO will take this electron, what he will get? 8 double bond 8. This is already, there is one electron come from outside, and this is load pair you know, and oxygen has 2 load pair, no problem. Now you know, when this nitrogen atom will take one electron, it becomes minus charge. That means we have drawn here NO minus. Like halogen, chlorine, bromine, iodine has the natural trend to take one electron to form halide ion. Why? To get octet. Very simple. NO will take one electron to get octet, to get effective number of electron around nitrogen 8. But you know, never you see NO minus radical, never you heard NO minus radical, laboring not. NO minus radical never exist. Although here nitrogen is octet. Now the question will arise, why NO minus radical not exist? Remember, see my explanation. This lone pair, and nitrogen lone pair. In double bond, you know bond multiplicity decreases the distance. Now the lone pair are very close to each other. Not only close to each other, when there are minus of nitrogen, you know its electropositivity highly increases. Not like nitrogen, neutral nitrogen electronegativity, but N minus is electropositive like beta. Its electron cloud is expanded. Now expanded electron cloud of N minus and electron cloud of oxygen. There you will get huge repulsion. And due to this huge repulsion, remember, this radical never exist. Never exist. Although you got in the structure, both atom is octet, but it will not exist due to huge repulsion between the expanded load pair N minus and NO. Now, question will arise. I'll take a simple analogy. See, from this structure, I'm going to draw another molecule. You know N minus, number of electrons around N minus 6, like oxygen. This is oxygen. That means N minus and oxygen, isoelectronic, number of electrons same, as well as isolobar, that means number of orbitals same. That means structurally, you can replace N minus by oxygen. The N minus, if I do replace by oxygen, you got the simple oxygen molecule that I have taken the first example. Now the question will arise, sir, oxygen exists, but NO minus not exist. You know, yeah, 21% that is oxygen. Without oxygen, we can live. Our life, is it possible we can go without oxygen? Oxygen simply exists, highly stable molecule, but NO minus not exist. See the difference. You know, this is oxygen neutral molecule. Its electronegativity much more greater than nitrogen and very much greater than N minus. That means its electron cloud is not expanded electron cloud. This electron cloud attracted by the high electronegative oxygen nucleus. Their repulsion is not prominent repulsion. That's why oxygen molecule freely exists and it is a stable. Remember this. Now, it is you failure to form the octet, to form NO minus. NO minus not exist. Now I will do another way by which nitrogen will get octet. From NO, I have drawn here NO. I'll remove this electron. You can confuse, sir. If I remove one electron, then how it will get octet? See the magic. By removing electron, I get octet. Remove this electron. Neutral, enormous paramagnetic that I have discussed. Remove this electron. Any oxidizing agent, take an electron from nitrogen. Sir, now the number of electron now nitrogen becomes 6, not 6. See, by removing electron, how you will get a vacant orbital. And this is a pair of electron. And here you will get plus charge. Since what electron gone from nitrogen. And it is a double. And remember, when it is a plus, its electronegativity highly increases. You know, N plus is more electronegative than fluorine due to this plus charge. Electronegativity means attraction brought towards the electron. Now, see, effective number of electron you see apparently 6. 2 plus 2 plus 2, 6. So how it is octet? I told you in the beginning how a bond will form. A pair of electron can form bond with a vacant orbital, and this will donate, nitrogen plus will accept, and a bond will form. Since you know when a bond will form and huge amount of energy release, and system will get huge stability. And you will what we get? You will get N triple bond, N double bond. It was N double bond O. Now you got N triple bond O, and plus charge goes on oxygen. What advantage you got here? It is a triple bond. And you know why additional bond means more than 200 kilojoule per mole energy release. That means it's huge stable. It was NO double bond. You got here triple bond. Now the effective electron 2 plus 2 plus 2 plus 2, 8. Here also 2 plus 2 plus 2 plus 2, 8. That means no disturbance. Without disturbing the octet of oxygen, nitrogen gets octet. That is the interaction between the atoms. It is not like our present society. They are always thought about the total stability. They never selfish. Atoms never selfish. Always they thought about the total stability of the molecule. That's why oxygen donate, nitrogen make vacant orbital accept, a triple bond with thought, and NO plus is available radical in our chemistry. The NO plus NO, when form NO plus, it will both atom will get octet, and it is a highly stable radical. Now, see, but a new magical soy. You know, nitrogen number of electrons, 7. Carbon number of electrons, 6. Both belongs to period 2. Now take one electron on carbon, make it C minus. So when it is C minus and nitrogen, both are isoelectronic with 7 electrons, that means structurally you can replace a nitrogen by C minus. I'll do replace nitrogen by C minus. C double E, C triple dot C, and put a lone pair right here minus, and oxygen. This is plus. See the molecule. You know, this is a poisonous carbon monoxide. It is a carbon monoxide. Carbon monoxide and a plus same structure, since they are isoelectronic and isolobal. It is poisonous, but it is non-poisonous. I will go to another way to get octet of nitrogen in NO. See the another way. Now, dear students, we'll make nitrogen octet. Since we know it is a 7 electron, we'll make octet by another way. Previously, NO minus is failure, NO plus got good result, NO plus is available already. Now, take two NO molecule, NO. Simply, there is a lone pair on nitrogen and there is a orbital with sigma electron. Take another NO molecule. I'm drawing a load pair only on nitrogen. Oxygen is not participating atom here. No. See, I told you, a singly occupied orbital can form with a singly occupied orbital, and they can make a covalent bond. Now, what you will get? We get O double bond L, and you got a new bond between N and N double bond O. On oxygen, there are two lone pair. On oxygen, there are two lone pair. On nitrogen, two lone pair. Nitrogen, two lone pair. And nitrogen, when the valence is 3, always there we get one lone pair on nitrogen. Oxygen, when valence is 2, normal valence, always there we get two lone pair of electron. You got a molecule new, which is called dimer of heaven. And its formula is A2O. NO has a natural trait to form dimer. Why? Why it will form dimer? Since it has odd electron molecule, it will try to get octet. To get octet, it will form dimer. And A2O2 is a common dimer in law of NO. Now tell me, what property change when it will form dimer? Actually, in liquid state, N2O2 exists as dimer N2O. NO exists as N2O2. What property change? Focus. Previously, I told you it was paramagnetic. And this was paramagnetic due to this odd electron. Any odd electron molecule is paramagnetic. Since you know, due to spinning motion of electron, the magnetic field generated is not cancelled out by other. Now, in N2O2, there is no odd electron. That means it is a diamagnetic species. And you know diamagnetic, which are feebly repelled by the magnetic field. Now, by electron dot, by taking simple concept of orbital, we have drawn complicated structure, new structure. How can form a molecule that is NO3, NO minus not exist, NO plus you can explain. In the next class, we will discuss by taking the simple concept. Another example of the molecule, another important example of molecule. Always stay with us. We'll discuss another example, complicated example by taking this simple concept. Thank you.